My dear students, today we will discuss about a few more concepts related to signal system. That is about complete response of a differential equation. Already we know that how we can calculate the natural response and forced response. Then what is complete response? Complete response is denoted by y of t. That is here they told that the complete response is equal to sum of natural response and forced response. That is for this both the input and initial conditions are considered. Here complete response means it is nothing but the sum of the natural response and the forced response is called as complete response. Now, with an example, we will discuss about the complete response. With an example, we will discuss about how we can find out the solution for this differential equation. How we will find out the complete response of this differential equation. For example, determine the complete response of the system. That is d square y of t by dt square plus 5 dy t by dt plus 4y of t equal to dx of t dt. And with the given some conditions that y of 0 is equal to 0, dy of t equal to dy of t by dt, that is t equal to 0 equal to 1, and x of t equal to e raised to minus 2t u of t. They have, with the conditions they have given what is the differential equation for which we have to calculate the complete solution. That is solution. They are given the differential equation, that is what d square y of t by dt square plus 5 dy of t by dt plus 4 y of t equal to dx of t by dt. The complete response will be given as yt equal to y of nt plus y of pt. That is here, that is y of nt is what? The natural response. Here forced response we represented by, that is y of p, that is particular solution. That is the given, that is y of t is nothing but the complete response. Therefore, this is sum of the natural response and complete forced response. That is nothing but the complete response. Therefore, already we know that how we can calculate the natural response, and also we with some equations we also solve problems related to forced response. Today we will discuss some concepts. It is with a problem we will find out how we will find out the complete response, which is denoted as to determine y of, first we will determine what is natural response, that is y of y raised to n of t. First we will find out that one and substitute in the equation. Then we will find out what is the particular solution. Then both will add, so that we will get the complete solution of this differential equation. Now we will find out what is how we will find out natural response. Steps are there. Here roots of the characteristic equation. Here n is equal to 2. Hence from given differential equation we can write here n is equal to 2. How we have we can tell n is equal to 2 means this is what this is I think already I have made a lecture, video lecture on this. Okay, I don't know if I have done, no problem. Once again I will do. Okay, no problem. That is n of 2 equal to here. That is the order of differential equation. 2 means here what is the order of differential equation? It is d square y of t divided by dt square plus 5 dyt by dt plus 4 yt. Here highest order is 2, therefore n is equal to 2. Hence from given differential equation we can write the characteristic equation, that is how we can write r square plus 5r plus 4 equal to 0. Here you see the, that is from equation. Okay, here from equation, that is I think Here they have not mentioned the equation we have to use. So in the previous class, there is some equation is there. From that equation, we can find out what is the, that is here n is equal to 2. Therefore, here the characteristic equation will be r square plus 5r 5y, because that is already that is what summation of k equal to 0 to n a raised to a of k r raised to k. I think in the previous class, while determining the roots of the characteristic equation, this is the equation. Here, how we obtain the roots of a character. This is the equation. From this equation, you'll find out the characteristic equation, that is r square. Why? Because here only 1 is there. Here d square 1 is there only here. Here 5 means that is here. Why? This is here it is. This is constant 5 dy t. Here 4 is a0 is 4. A0 a1 is 5 and a2 is 1. So anything is not there means we will consider it as a r square plus 5r and plus 4 equal to 0. This we will get this equation. Then solving this equation so that we can find out the roots of this equation will be, that is r1 equal to -4 and r2 is equal to -1. So that by analyzing we'll come to know what are the roots of this equation. We'll get r1 and r2. Next step is what? A form of natural response. For real roots, then for form of natural response, for real roots, y of n equal to c1 e raised to r1 t plus c2 e raised to r2 t from equation 3.2.5. Here you see from this is the form of natural equation. They have mentioned equation 3.5. In this equation we have to substitute the values. For example, I think here where this is 2.2, 2.3. Here too. In this, the natural response of the system of a following form. While deriving the natural response, that we have derived this equation. From this, this is the equation from which we can calculate the natural response. That is the natural response of the system of the following following form. That is y raised to n equal to summation I equal to 1 to n ci1 e raised to r it. That is 3 point. In this equation, from this equation we will get this equation. That is what? That is this equation. That is y raised to n t equal to c1 e raised to r1 t plus c2 e raised to r2 t. This equation that is form of natural response. This is why natural response will be like this. Here already we have found out what is r1, what is r2. Substitute these values in this equation. Then it will be c1 e raised to -4t and r2 equal to c2 e raised to -t. That is substitute the value of r2 as -1. Then we'll get y raised to of n. That is this equation we will get. This is the equation we got for natural response, but still we have not found out what is the value of c1 and c2. Afterwards we'll find out what is the value of what are the constants values of these c1 and c2. Okay, before that we will find out the particular solution. Already we know that the complete response consists of natural response and particular solution. Here particular solution. Step 3, that is form of particular solution. That is the input is x of t equal to e raised to -2. That is in the equation x of t input is what? It is for x of t equal to e raised to -2t u of t. When this is the equation, Then hence from the table 3.2.1 the particular solution will be of the form y of pt equal to k raised to e raised k into e raised to minus 2t. This table is important. You should know this table. From this table we can come to know what is particular solution. They were given some table. From that table we can find out the particular solution. This is the table here. That is the table 3.2.1 shows the typical inputs and equivalent forms of particular solution. That is what here e raised to minus x equal to e raised to minus 80 is there. If input is like this, then what is particular solution? Particular solution is k raised to e raised to minus 80. Here in place of a, 2 is there. Here if it is input is e raised to minus, here what is that? Right. Input is x equal to e raised to minus 2t is there. Then particular solution will be, if it is in e raised to input is e raised to minus 80, in place of a we are having 2, that is e raised to minus 2t, then particular solution will be k into e raised to minus 2t. That is particular solution. You have to remember this table. This table is important. From this we will get what are the particular solutions. Therefore particular solution will be of form referring the table we will come to know what is particular solution. The particular solution is k into e raised to minus 2t. Then from next what we will find out, we will find out what is the value of k. What is the value of k? Here step number 4, value of k. Find out how we can find values of k. What is the value of k? Therefore putting y t equal to y of pt equal to k into e raised to minus 2t and x of t equal to e raised to minus 2t e of t in equation this, then you will find out what here putting y of t equal to y of p raised to p y raised to p of t equal to k into e raised to minus 2t and k of x of t equal to e raised to minus 2t. In this, substitute this value in the equation 3.2.7. That is what this is. Where is the equation? In this equation. This is 2. Which this equation only. In this equation, this is the solution. Whatever problem in this, for example, equation, what is this? In this equation, substitute value of yt as k raised to e minus 2t in this equation. K raised to d square. In place of yt, what we have to substitute? K into e raised to minus 2t divided by dt square plus 5 d in place of yt, what we are to write? K into e raised to minus 2t dt. Then 4 plus y is what? K into e raised to minus 2t. Like this we have to substitute that one. Then and also here this is like this. Then d square divided by dt square into k into e raised to minus 2t plus 5 d by dt k into e raised to minus 2t plus 4 into k into e raised to minus 2t equal to d by dt. d by dt. Here we have substituted, that is here x of t is what? Here in place of x of t in this equation, this is x of t. X of t is what? Your x of t is e raised to minus 2t. That we have to substitute that x of t value also. That is d by dt e raised to 2t. That is we have to place this value. Here d, it is not only x of t is there, d into x of t by dt. What is x of t? This is x of t. Therefore, it is also becomes d by dt into e raised to minus 2t. That is nothing but x of t. Therefore, when we substitute these values, when we do the differentiation d square, that when we differentiate this equation, what we'll get minus if one time we differentiate, what value we get in this first term, we'll get what this is first we'll got in this equation. When we differentiate it, we'll get minus 2 k into e raised to minus, but it's two times we have to differentiate this. Therefore it becomes minus, once again minus 2 it becomes plus 4 k into e raised to minus 2t minus then differentiation of k into e raised to minus 2t. Here we are differentiating with respect to what? We are differentiating with respect to t. Therefore it is therefore here t is there. We are differentiating this with respect to t. Therefore it becomes 10k into e raised to minus 2t plus 4k into minus e raised to minus 2t equal to minus 2. Here also we have to do the differentiation, that is dt with respect to dt. We are having, when we differentiate it with respect to t, then what will get value? Minus 2 e raised to minus 2t. That is how we'll get this equation. When we solve this equation, then it will be k equal to 1. From solving this problem, this equation, we'll get the value of k as 1. Hence, particular solution will become y of pt. That is, particular solution will be e raised to minus 2t. Why? Because here we have got k value as 1. 1 into anything is the same thing. 1 into, even though if we write 1 into e raised to minus 2t, that will be same as e raised to minus 2t, because since k value is 1. Next, that is to determine y of t, the complete solution. The complete solution will be putting y of pt from above equation and y raised to n, putting y of pt from above equation and the y of n of t from equation 3.1 equation, that will get complete response. That is substitute the complete response is what? The natural response. Here what we found this one. This is the natural response of this, and this one also particular solution. Substitute in this equation, in this form, in this equation, so that we'll get the complete response. We'll get the complete response is what? Y of t equal to c1 e raised to minus 4t plus c2 e raised to minus t plus e raised to minus 2t. You will get this. But here this is not over, since we have to find out what is the value of C1 and C2. Then how we can find out? Therefore, few more steps we have to follow few more steps to find out the value of C1 and C2. Values of C1 and C2 with initial conditions, putting y0 equal to 0 in our equation, then y of 0 equal to 0 means the value of t will be 0. Then y in the initial conditions, they have given in the starting problem of the starting only, they have given that with y of 0 equal to 0, dy of t by dt when t equal to 0 is 1. Like they have given the initial conditions. Therefore, when y of 0 is 0, we have to substitute 0 here in this equation. Suppose here in place of t in this form, in here, suppose we substitute here, that is this one c1 into e raised to minus 4t. In this, suppose we substitute the value of t as 0, then 0 anything multiplied by that will be complete. This term will become 0. Therefore, it will be e raised to 0. E raised to 0 is what? That is 1. Therefore, we are having only 0 plus c1. Plus here also, so substitute the value of 0 here. Therefore, what happens? E raised to, this complete term becomes 0. E raised to 0 is 1. Therefore, we are left with only c2. Here in this, e raised to minus 2t is there. Substitute the value of t is 0, that will be equal to 0. E raised to 0 is what? 1. Therefore c1 c2 equal to minus 1. Therefore that is c1, therefore c1 c2 plus c2 equal to, suppose 1 you take this side, it becomes negative, therefore c1 plus c2 equal to minus 1. Then we got one equation. Since two unknown quantities are there, therefore we have to have two equations, so that we can find out the two unknown values. Therefore one more equation, how we can obtain one more equation is that differentiate equation 3.22 with respect to t. Then it will be dy by dt equal to differentiate 3.2 this equation. Which equation they are telling? Differentiate equation 3.22 with respect to t. This equation 3.2, this suppose we differentiate this equation with differentiate equation this differentiation, we will differentiate this equation, so that we'll get one more equation. Now suppose we differentiate this equation with respect to t, what happens? It becomes d into dy of t by dt equal to, like this we will get the differentiation, dy of t equal to, then here c1 into e raised to 4t is there. When we differentiate it with respect to t, we will get minus 4 c1 e raised to 4t. Then when we differentiate this, that is this, here we will get what? minus 1 c2 e raised to minus 2t. When we differentiate this with respect to t, then it will be minus 2 e raised to minus 2t. Like this we will get this equation, putting dy of t by dt here in t is equal to 0 equal to 1 in our equation. Suppose substitute this, put this value in our equation. In problem also they have given the value of what is dy of t by dt, it is equal to 0 equal to 1. This they have given one more initial condition, that is dy of t by dt equal to 0, t is equal to 0 equal to 1. Substitute this value in our equation, then it will be 1. That is here in this equation 1, this will be 1, and here in this equation substitute the value of, here in this substitute the value of t as 0. When t as 0, then complete this will, it is e raised to 0. E raised to 0 is what? 1. Therefore we are left with only 4c1 minus 4c1. Like here also substitute the value of t as 0, it becomes e raised to 0, then it is 1, then it is minus c2 minus it, then minus here also e raised to t is 0, then it will be 1, therefore we are left with minus 2. Therefore 4c1 plus c2 equal to minus 3. 4c1 take these two this side, they will become 4c1 plus c2 equal to, this one you take that side, that will be equal to 4c1 plus c2 is equal to minus 3. Solving our equation, and equation 3.2 we are having we got two equation. This one equation, we got this equation, and also we got one more equation. Since two unknown quantities are there, therefore we require two equations. Solving these two equations, we will get the value of c1 as minus 2 by 3 and c2 equal to minus 1 by 3. Like this we will get the values of c1 and c2. Substitute these values in this equation, y of t equal to, in this, that is complete response equal to c into c1 into e raised to minus 4t plus c2 e into c2 e raised to minus t plus e raised to minus 2t. In this substitute the value of c1 and c2, therefore the complete response y of t will be, here c1 is minus 2 by 3 e raised to minus 4t, that is c2 is minus 1 by 3 e raised to t. Why here in this equation, when we substitute here, that it is c1 value, c2 value, then it is 1 by 3 e raised to t plus e raised to minus 2t as it is. Therefore, this is the complete response. This is the required response for system considering input as well as initial conditions. This is how we can obtain the complete response when they have given the such problem, such a differential equation, and ask you to find out, determine the complete response of the system. Okay, this is how we can solve problems related to differential equations. Okay, next video lecture I will tell how we can obtain the complete response of a difference equation. Here differential equations are made used for the continuous time signal, and that is difference equations are used for that is what that is a discrete time systems. Therefore, in next video lecture I will explain about how we can find the complete response of a system of a difference equation. Okay. Thank you.